there, Dan Calloway again, coming at you, and I want to talk about secure shell connection in Linux today. I'm on my KDE Neon 5.12.0 Linux machine, and I'm going to fire up the terminal here in a moment. And today I'm going to demonstrate basically the creation of a public and private key pair to make the connection in Linux to using the secure shell protocol from a local machine to a remote server, rather than using password. And the purpose of that, or the reason for that, really is this: a typical user, it's not a problem if you're familiar with SSH at all. Making that connection using the SSH protocol to a user account on the remote server that you know the password for. Because when you make that connection, it's going to prompt you for that password, and you'll make the connection, and then your traffic to and from that server will be secure. That's okay for the typical user, but when you get into a Linux system administration environment where you're having to make that connection to the remote server multiple times during the day, then that becomes an administrative burden and very time consuming. And so what I want to do is show you a way to get around the password requirement and use a key pair that we're going to generate here on the local machine, public-private key pair with RSA encryption, and then you'll be able to connect to that remote server to administer that server as if you were sitting in front of it. Over the network, the difference being you'll have a secure shell connection, a tunnel, if you will, so that eavesdropping on the traffic to and from the the local machine rather to the remote server isn't possible. Okay, so let's go ahead and get in the terminal here. Let me fire the terminal up. Here we are in the terminal now on my local machine. Let me get the IP address for this machine, and you can see the IP address is 192.168.136. Okay, the machine that we're going to be connecting to is another Linux box running the SSH protocol at 192.168.1.85. All right. I will say before we move on that I'm talking about SSH protocol here, but actually in the modern day Linux distro we're really talking about Open SSH. It's been replaced. The old SSH protocol has been replaced with the open source version. So when I reference SSH, I'm really talking Open SSH. Alright, so let me go ahead and clear the screen here. Now let's go ahead and ping that server to make sure we have connectivity. So I'm going to use ping C-switch 3, so I'm going to send 3 packets to that server. And the address is 192.168.1.85. And so I'm sending 3 packets of 64 bytes. We've got 3 packets transmitted, 3 received, 0% loss, and 100% received. So we've got good connections. We've got a good route to that server, so now we can use SSH and not have to be concerned about it. So let's clear the screen again. Alright, so the first thing I want to do is make my initial connection with a password requirement from the local machine to the remote server. And to do that, I'm going to use the SSH protocol command in Linux, and then I'm going to use the username of the account on that server that I have the password for. So that is Data Pioneer as well at 192.168.1.85. Alright, the first time I make that connection, it warns me. It says the authenticity of the host can't be established. There's a ECDSA key fingerprint with a SHA-256 hash has been created. Says that, do I want to make the connection anyway? I'm going to say yes. And then it tells me that as a result of that, it's permanently added that hashed fingerprint to the known host file on my local computer. Okay, and so I'm waiting for it to come back to a prompt here for me. And it should be, if I don't get it, I'm going to cancel that, clear the screen. So if I do a cd into the .ssh directory on my local machine and take a look at that, the known host file that it copied that hash to is this one right here, and it's located under the home directory in a hidden directory called SSH, hence the dot in front of it. And notice it's not empty, it's got something in it, which is the hash, hopefully. And so let's do a more on the known host file. Take a look at it, and this is the hash that was created. This is what allowed me to make that initial connection to the server, which I'm going to have to do again because I broke it when I did a Control-C. Alright, so let me go ahead and clear the screen. Let me do an SSH again to Data Pioneer at 192.168.1.85, and it's asking me for that password again, so I'm going to put that in. And I put the right password in, it connects me. So I made the connection, and the way it made this connection was it looked at the known host file on this machine, looked to see if there was a hash that would secure the connection. It found it in the known host file that I just showed you, and so it allowed the connection to take place. And so the connection is there. I'm now looking at the machine remotely, which is the Data Pioneer at Pop! OS desktop, okay, which is the remote server running Pop! OS Linux, which is an Ubuntu distro as well. I can come in here and do a CD of the desktop to show you that I'm looking now at the desktop itself in the terminal. And so this is the contents of the desktop remote server, not my local machine. And traffic to and from this machine to the remote server now is secure. So I can make, configuration changes, add files, modify files, etc. on that server over this connection all day long. And if anybody tries to capture packets, they're not going to be able to read them because they're not plain text, they're encrypted. Alright, that's all well and good, like I said, for the typical user, but we're going to need to improve upon that. And so before I get out of this connection though to the remote server, let me change directory to the .ssh directory here and show you that what we have is nothing but a known host file. It's empty on this remote server, which means this remote server has never had an SSH connection made from it to something else. We've had one going to it, but not from it. And so there's no known hosts in this particular file. Alright, so let me go ahead and exit. Now I'm back at my local machine. Let me go ahead and clear the screen. So I'm back at Data Pioneer at my local machine, datapioneer.-kde neon. Alright, in order to bypass the password requirement, what I'm going to do is I'm going to generate a key pair, a public and private key pair, using RSA encryption 2048-bit. And to do that, I'm going to use a command key SSH key gen. Let me make sure that's the right command. Nope. SSH-keygen, which is the generator. Use the T-switch using RSA encryption, that's the type, and then the bit strength is 2048-bit. And so this is the command SSH-keygen type RSA bit strength 2048. I'm going to hit the enter key. It says it's generating the public private RSA key pair. Wants to know where I want to save it. Well, I'm going to save it in the default location, which is in the subdirectory .ssh of the home directory in that file, which is the private key. So I'm going to hit the enter key. It's asking me for a passphrase. Now you don't have to put one in, you can leave it empty. Highly recommend you do create a passphrase. And the reason for that is if you don't create a passphrase, somebody can capture your private key and use it all day long to match it to the public key on the server that we're going to copy up here in a moment and get in without a passphrase requirement. Okay, so let's go ahead and put in a passphrase and re-enter it. Alright, and it generated the key, and so we're looking at, this is the fingerprint of that key right here with a hash of SHA-256 with an RSA encryption of 2048-bit, Okay, and this right here is the random art image of that particular key. So we've created that key pair. If I take a look at the key pair, I'm on my local machine. So let's do a listing rather, where I'm already in the .ssh directory, where I saved it. You'll notice that along with the known host file, where we use the password requirement, we now have two files here additionally. One's called ID_RSA, that's the private key, and then the ID_RSA.pub is the public key. Okay, so both of those are on my local machine. All right. The next step in the process is I need to, let me go ahead and clear the screen. Well, wait a minute, I forgot to do something real quick. I want to look at the actual private key, or the public key rather. So I want to do a more on the ID_RSA.pub. Okay, and this is what the key looks like. All right. And I want to bring that to your attention because we're going to be comparing that key here in a moment when we copy it up to the server. So I'm going to leave it up right now on the screen. Okay, so what we need to do is we need to copy only the public key up to the remote server. We don't want to copy the private key. And we could do this manually and create that file on the remote server and load the contents into it. But there's a better way of doing it. There's a command you can use called SSH copy ID, and the IP address where you want to copy it, 192.168.1.85. And what that does is it's prompting me now for the password of Data Pioneer. And when I enter the password correctly, it adds one key to the server. It says right here, keys added, 1. Okay. It wants me to go ahead and log in again to that server using that SSH without the Data Pioneer in front of it to make sure that the key that was copied up is the one and only key that I want copied, which is the public key, not the private key. And so I'm going to go ahead and put in SSH and get rid of that. SSH 192.168.1.85. And it's going to take a few seconds here. So, there we go. No route to host, so something happened to the route. Let me go ahead and ping it again. Make sure it's still good. It's still good, so I need to refresh the route. So let's do an SSH 192.168.1.85 again. And it's asking me for the passphrase for the key. And let me put that in. And I entered the correct passphrase, and so it connected me. So I'm now connected to that remote server, which is Pop! OS desktop. Okay. And I used the passphrase this time instead of the password to get in there. The reason I was able to do that, well, I'll show you right now. So let me do a CD to the SSH directory here on the remote server, and let me run a listing on that. And you can see there's now a file that wasn't there before called authorized keys. Okay, it's not empty. Hopefully it has the public key in it. Okay, we copied up using the SSH copy ID command. And so let's take a look at that. More on authorized, oops, two Z's, no, keys. Okay, and this is the key that was copied up. Okay, it's the contents of the key that we're looking at. And this should be the public key. So notice it has 4 A's, B, 3 N. So let's go up the screen, which is where I had left the key contents for the public key down on the local machine. And it's identical, 4 A's, B, 3 N. So this is the public key here that was on the local device, local platform. Here's now the key that was copied up to the server. They match. And so it is the only key. One key was copied, and it was placed automatically in a file that it creates on the fly called authorized_keys. Okay, so that way when I log in with SSH from the local machine to the server now, it looks at the authorized keys file. It takes the public key and matches it against the public key that corresponds to the private key on my local machine at 192.168.1.36, and if they match, it lets me in if I enter the correct passphrase. Okay, that's all well and good again, but then what we've done basically here is we've replaced the requirement to enter a password with the requirement to enter a passphrase, and that's still not going to be good enough because that's still an administrative burden. So let me go ahead and exit the server, get back to the local machine. Let me clear the screen again. And now what I'm going to show you is a way to get around entering a password or a passphrase, and that is by taking an agent called an SSH agent and opening the agent, setting the variables within the agent, and copying them into random access memory on the machine, and leaving them there so that we'll allow the SSH agent to make the connection for us so that we don't have to enter a password or passphrase. All right, and so the process to do that is pretty straightforward. The first thing we need to do is invoke the agent. And so what I'm going to do is, when I'm on my local machine, SSH agent is the command, and what the two variables that I spoke of earlier, SSH_auth_sock right up here, and SSH agent PID, okay, are here, and they are currently unset. Okay. All right. So what I need to do now is I need to copy those up to the memory location. Now I could do this, manually by stopping the SSH agent using a command called SSH agent K for kill. Could do that. But what I'm going to do is I'm going to go ahead and just show you that there's another command that I can use to do that for me, which is called the eval, and then I'm going to have space, but I'm going to use the back single quote, not the regular single quote, but the back single quote, which is the lowercase tilde key on your keyboard, and then use the SSH let's see here, yeah, SSH agent and back tilde. What that does is the thing is that is in the back tilde or back quote, single quote, with the eval command, what it does is it takes that and evaluates that and processes that rather than treating it as text. Okay, and so I enter, and it tells me that the agent PID is 3515. All right, so that has copied that up to memory. Now I want to take and unlock the private key on the host and add it to the agent. In order to do that, I'm going to run the command SSH add. Hit enter. It's asking me for the passphrase to the private key on the local machine. That's the same passphrase we used on the remote machine. Make sure I enter it right. Okay. It says identity has been added, so now I've added the identity to the SSH agent. Okay, so the agent now is going to work for us to make the connection, as opposed to us having to do it with a password or a passphrase. All right, so let me clear the screen. I'm still on the local machine, and now what I'm going to do is show you that I'll make the connection. The agent's going to jump in the middle between me and the SSH connection to the remote server, and it's going to make the connection for me, and so I won't be prompted for a password or a passphrase. So let's do SSH 192.168.1.85, and I'm connected. So the agent stepped in for me and assisted by taking the private key that I added in memory and made the connection for me, and I wasn't prompted for anything. It just supplied what the server needed on the other end at the remote connection to make that connection. All right. Now, one of the things you need to keep in mind is you need to keep the terminal open at all times. You can, minimize it or whatever you want to do, and then you can just, reopen it as needed to make that connection if you break it. In other words, I can exit this connection right now and then come back in again by running this SSH 192.168.185 again if I want to, and that's not a problem. It's when I close the terminal session, where I'll run into an issue, and what I'll need to do at that point is I'll need to run the eval statement again. So I just broke the connection to show you, okay? And so I'm back at the local machine again. So if I do an SSH 192.168.1.85, it made that connection to the server again, no problem, okay? Let's go ahead and exit the connection again, and now I'm going to exit the terminal altogether and show you now that the session's been broken. If I come back in here and try to make that connection again, it's going to prompt me for the passphrase, all right, because it's now dropped out of memory. The SSH agent doesn't know what the private key is anymore, as I've closed the terminal session. So let me do an SSH 192.168.1.85 and show you it's asking me for the passphrase. Let me just go ahead and enter it. All right, made my connection there, okay? So I'm going to go ahead and break the connection. Get back to the machine, local machine. Now I'm going to run that eval statement again, invoking the agent once again. There's the new PID 3558. Now I'm going to do an SSH add. Here's the passphrase on the local machine. Now it's the private key's been added back in memory again, so that with the agent, so the agent has it. All right, and so now if I clear the screen, I'm still on my local box. If I do an SSH 192.168.1.85, now it's made the connection for me, or should. It's going to take a few seconds here. Seems to be having a problem with this route 192.168.1.85 today for some reason. There we go. Alright, so I'm now reconnected to the server again, and let's take a look at let's do a listing rather of the location of the authorized keys, and the authorized keys hasn't changed or anything like that. Notice the known host file was not in play at all on the remote server. Okay, so let me go ahead and get out of it. This has been a video that demonstrate secure shell connectivity using a public-private key pair in Linux, and then invoking the SSH agent to assist in making the connection without having to use a password or passphrase. So if you were a Linux admin, you could make that connection all day long just by typing in SSH and the IP address of the server you want to connect to, and bingo, you're in. Have a nice day.